I'm Dr. Ramesh Pothuraju, currently working as a scientist in Rajiv Gandhi Center for Biotechnology. I have joined late December 2023 in Cancer Research Program. Our lab is interested in to understand the importance of the intestinal mucous layer and their role in disease conditions. Like we are mostly focusing on the mucins. These are the glycoproteins which are synthesized and secreted from the goblet cells. And these mucins are differentially regulated in disease conditions such as cancer. So our goal is how these mucins are involved in the cancer progression, especially we are working on the colorectal cancer. And further we are also interested to understand their role in the drug resistance. In another aspect, our lab also interested to know the impact of the fiber, mostly the dietary fiber, and their impact on the metabolic disease associated with the colorectal cancer. Mostly we are focusing on the obesity. Obesity is a metabolic syndrome which is associated with insulin resistance, diabetes, and further leads to the cancer. Our lab is mostly important to understand how this obesity, which is directly linked to the colorectal cancer progression. To understand for this, we are going to induce the obesity by using in vivo models where we are feeding mice to high-fat diet, which will induce the obesity. Further, we are using these animals crossing with the genetically engineering a mouse model, which is APC. APC is a tumor suppressor protein which is completely absent in the disease progression. So these animals which are using and we're feeding with the high-fat diet to induce obesity associated with colorectal cancer progression. And once we have induced these animals, we are supplementing the dietary fiber, which we identified the gamma cassia, which is an important dietary fiber, which has 80 to 90% fiber which is present in the gamma cassia. We want to know what is the effect of this dietary fiber gamma cassia to prevent the obesity associated colorectal cancer progression. So for that we are formulated gamma cassia with high fat diet, and we are going to fed these high fat diet to the C57 and BL6 mice, and where we are going to look into the preventive effect of the dietary fiber which is linked to the obesity associated colorectal cancer. After that, once we establish these obesity-induced colorectal cancer, we are going to do the fecal material isolation. Then from there, we are going to profiling the gut microbes as well as the metabolites which are coming from the gut microbiota digestion by the dietary fiber. So once we have identified the gut microbiota as well as the gut micrometabolites, we are going to establish what kind of metabolites which are really involved in the prevention of the obesity and which are associated with the colorectal cancer progression. After that, what we are going to do, we are also willing to perform the fecal microbiota transplantation. The fecal microbiota transplantation, or FMT, these days is very important role. Use this transplantation of fecal microbiota from the healthy donor to the disease condition, or healthy donor to the disease condition, people such as inflammatory bowel disease and any cancer. Recent studies are identified that transplantation of the fecal microbiota to the disease people, it is 80 to 90% survival improval as well as the overall improval of the gut health. So we want to know what kind of gut microbiota which is present in our established obesity mice model. Once we establishing these gut microbiota profiling, we are using these microbiota as a FMT, as a fecal microbiota transplantation to the already established obesity induced colorectal cancer, where we are going to identify how this altered gut microbiota will be replaced by the supplementing new flora to prevent the obesity associated colorectal cancer. And further, we are also trying to understand what is the molecular mechanism which are involved in the prevention of the obesity associated colorectal cancer, and also as well as the mucins role in the prevention of the colorectal cancer progression as drug resistance. And we are having a great team, and we are working parallel with multi-omics, as well as we are going to try to the RNA sequencing and metabolomics by using all these various techniques which we are connecting to understand the molecular mechanism, as well as we want to connect link between the how the intestinal mucous layer and diet and gut microbiota crosstalk, which is crosstalk in the prevention of the colorectal cancer progression as well as the drug resistance.